Hello, everyone, and welcome to the RCSI Cardiovascular Society ECG of the Week. This week, we're going to kick off with ECG basics and just do a quick review of some of the core concepts of reviewing and interpreting ECGs that we'll be using on a weekly basis with some of our other cases that will follow in the series of ECG of the Week. So, to get started, here's the anatomy of the ECG. As we know, the ECG is the marker of electrical activity in the heart, and those things are accompanied by mechanical activity as well. So you have here just a outline of the order of conduction of electrical impulses, starting at the SA node, passing down through the AV node, ultimately terminating at the ventricles. And then this is essentially your just a aspect of your ECG tracing. The things that we'll be looking for in all the tracings we review are P waves, these components of the ECG, and the P wave is atrial depolarization. You have the PR segment, which that is the delay through the AV node, which slows down the conduction. Then you have your QRS complex here, which is ventricular depolarization, the ST segment, and then, of course, your T wave, and that is ventricular repolarization. So the goal is to have a systematic way to approach ECG. So we're going to use the 6-step method. We'll review that in detail in this video, and then in subsequent videos, we'll kind of be using this as our bread and butter for determining and interpreting ECGs. So these are the 6 steps: rate, rhythm, P waves, QRS complex, PR interval, and the ST segment. So we're going to start with rate, but just before we get into that, this is just your kind of standard ECG tracing, 12 lead, just to kind of show you about what's on the x-axis here is time. So in all of these, in the entire tracing, you have these boxes here. So these are our small boxes, and there are 5 of them. And then those small boxes are 0.04 seconds. And then the 5 of them together make one large box, which is 0.2 seconds. And that becomes important when we look at certain intervals and certain durations and determining the rate as well. So determining rate. So the rate for our ECG, we know normal rate is between 60 and 100 BPM. Anything below 60 is determined as bradycardia, and anything above 100 is then tachycardia. So how do you determine the rate for your ECG? Well, there's 2 methods here that we can use. One is the 300 method, and that is probably going to be our bread and butter here. It's quick, it's pretty easy. The one kind of downfall is that it requires a regular rhythm, so you'll have to assess whether the rhythm is regular in your ECG before you start using this method. But what you want to do is you find your RR interval, like between 2 R peaks, and then you count the number of big boxes, and then you divide 300 by that number. And this is kind of an idea in this table of, one big box between your RR interval is going to be 300 beats per minute. 2 big boxes is going to be 150, of course, because 300 divided by 2 is 150, and so on and so forth. The other method we can use is the 10-second method. Now, this one, the beauty of it is that it can be used for any rhythm, regular or irregular. You do need a rhythm strip or the entire ECG printout so that you can then count the number of R waves in a 10-second period, which will just be the length of the ECG, and you take that and you multiply that by 6. So just to kind of determine rate on a few examples, here you have an ECG, and the first thing we want to do, of course, is determine, is this rhythm regular? What you can do is you can make marks at all of the R points, like so. And then either, I'm going to use my cutout here, but you can use a separate sheet of paper. And what you do is you move it over, and then you'll see that the marks that you made line up as you're kind of shifting over to subsequent R peaks. So that is a good quick way to determine that the rhythm is regular. So now that we know that, we know we can use the 300 method to determine this rate. It's always best if you find perhaps a peak that almost lines up on the beginning of a big box, so that one looks pretty good. And then you want to count how many big boxes are in between this RR interval. 1, 2, 3, 4, and like not quite 4, but you're close enough. And then for the 300 method, we do 300 divided by 4. That equals 75 beats per minute. And that's a good quick way of determining the rate for this ECG. We'll go to a different example. So this one you see there's a lot more R peaks here. So again, we can determine if the rhythm is regular by marking these and seeing if the RR peaks line up. But just to show you an example of how to use the 300 method, this whole strip is 10 seconds. So what we can do then is count the peaks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So we have 27 peaks there. And if we're going to use the 10-second method to determine the rate here, we had 27 peaks like we said. You want to multiply that by 6. And that's going to give you a rate of 162 beats per minute. And that's a pretty good indicator. Again, this 162 BPM is indicative of a tachycardia, and the rhythm is normal, so this is sinus tachycardia. Here's another example, again, just of an ECG that we're just going to go through. I'm just going to tell you that the rhythm here is regular, so we can use either the 300 method or the 10-second method, but the peaks are lined up so nicely, we'll just use the 300 method to determine this. So here is your first big box, and we're going to count between this and the next R peak. 1, 2, 3, 4, 5, 6, 7, 8, and then we have 300 divided by 8. That equals 37.5, so we'll round that up to 38 beats per minute. And this is far less than 60 beats per minute, so this is a good example of sinus bradycardia. So for determining rhythm, we've seen a couple of examples of regular rhythm. Like I said, you just mark the RR intervals, and then you're going to shift to subsequent R peaks and see if the distance between them remains the same. When your rhythm is irregular, you can use the same trick and just see if the peaks line up if you move them across. So here we have our 3 peaks marked out, and you can see as I move it over, they don't really line up anymore. And so that would mean that this is an irregular rhythm. And then the subtype of irregularity, once you determine that, is it irregular with a recurring pattern, or is it irregularly irregular? And same trick we can use here to determine if there's a repetition in the irregularity. And in this case, you can see there really isn't any repetition in that irregularity. So this is, we call an irregularly irregular rhythm, which is pretty indicative of atrial fibrillation. So that's rhythm. The next thing to look for is P waves. So we know P waves are atrial contraction. That's the depolarization of the atria. Basically, we're going to look to see if P waves are present, and then look to see if they are followed by QRS complexes. So looking at your ECG here, we want to see where are your P waves. There's a P wave there, P wave there, P wave there. And you can see just all the way along, you can get those indications of present P waves along the entire strip. And then the next thing to look for is, once you've identified the P wave, does a QRS complex follow it? And in this case, yes, we do have a QRS after every P wave, so we know that that's normal conduction at every atrial contraction is coupled with a ventricular, or atrial depolarization is coupled with a ventricular depolarization. So then the morphologies of our QRS complex. So a nice normal QRS complex looks like this, very narrow. This is QRS, following the P wave. So they're very narrow. The rule of thumb here is that you want your QRS complexes to be less than 120 milliseconds. So thinking back to our x-axis of time, we know one small box is 0.04 seconds. So this would be 120 milliseconds would be any QRS complex less than 3 small boxes, and that's what you're going to look for. And here's a pretty good example of a QRS complex there. This is one small box which fits in the less than 120 millisecond time frame. This second tracing shows a much wider QRS complex, and you can tell by looking at it. After you do your QRS morphology, you want to look at your PR interval. So the PR interval is the duration from the beginning of the P wave here until you hit the beginning of the QRS complex. And the normal duration is 200 milliseconds or less than 200 milliseconds, and this would be less than 5 small boxes. So here's an example. We've seen a lot of normal examples of regular PR intervals. So if you have a P wave here marked by this circle, then you'll start here, and then you want to see how many boxes it is till you get here to the Q. Our beginning of the QRS complex, this is 1, 2, 3, 4, 5, 6, 7. And they have much larger or larger than 5 small boxes. So this is a prolonged PR interval. And that's one example. Here's a second example, again, where you have your beginning of your P wave here, and then this is the beginning of the QRS. So this is kind of 1, 2, 3. Okay, that's 3, which is less than 5 small boxes. That's pretty good. The next one you have starting here and ending here. This is 1, 2, 3, 4, 5. So maybe a little bit less than 5 really. That's getting a little bit longer. And then here's the beginning of the next one. And then we count that one out. 1, 2, 3, 4, 5. 6, and there's a little bit more because it really starts here, a little bit more there. So you can see just by these markers at the bottom that the PR interval is getting longer with each subsequent beat. So any increased duration of the PR segment is going to be indicative of some sort of atrioventricular block. And now you move on to our ST segment. Now, ST segment is the isoelectric segment of the normal ECG. After your QRS complex, usually your ECG comes back to an isoelectric point, something called the J point, which is what we expect to see before we then get our T wave, which is our repolarization of the ventricles. So you have 2 instances where that won't happen. So ST elevation, which indicates myocardial infarction. So that's full transmural thickness, transmural infarct of the myocardium. And here you can see this is kind of your isoelectric line going across the ECG for the most part. This is your QR, this is your S wave, and as it's coming back up, you expect it to hit the isoelectric point, but it actually goes above, and this is actually where the J point sits. And then you have this high peaked T wave, and so this is pretty classic ST elevation. The other morphology you can get is ST depression, which is indicative of myocardial ischemia, so not that full transmural infarct. But what you get again here is your isoelectric line going across as you're coming down the S wave. You expect it to go back up to the isoelectric point, but as you can see, it stays low and then proceeds into the T wave. So that's ST depression, and there's a couple of morphologies of ST depression. Upsloping, you have downsloping here, and here you have a horizontal or flat ST depression, but that all kind of indicates ischemia of the myocardium. So what are our main takeaways here? So we want to be systematic about how we approach our ECGs, so that's why we're using the 6-step method here. The first thing that we want to always do is look at our rate. So we have 2 ways of determining the rate. The 300 method, which you take 300, right, and you divide the number of big boxes but in the RR interval. And just remember that the rhythm has to be regular for you to be able to do this. Whereas in the 10-second method, you can use it with any type of rhythm, regular or irregular. and then you can determine your rate that way. Again, rhythm, regular, irregular, you use your little tally marks and you move them across your ECG tracing to see if they match up. If it is irregular, have a good look at it and then determine if it's irregularly irregular, which is basically going to tell you that this is a ECG that's showing AFib. Look for your P waves. The first question you ask are they there? And then the second question is, if you are seeing P waves, is there a P wave before every QRS complex? And we want to see this normally. That indicates, again, normal conduction from the atria down into the ventricles through the AV node. Looking at your QRS complex morphology, is it narrow or is it wide? So we want a normal narrow QRS complex to be less than 120 milliseconds or 3 small boxes. Wide QRS complexes indicate some sort of ventricular arrhythmia, like VTAC or VFib, and that's when you'll start to see wide QRS complexes. Go back, have a look at the PR interval. The normal interval is less than 200 milliseconds, so less than 5 small boxes. Anything that's larger than that is going to be caused by some sort of AV conduction issue. And then the ST segment, you're really looking for that return to the isoelectric point after your narrow QRS complex. You want to see this return to isoelectric point at the J point before the T wave. And, if you see any present elevation or depression, you're looking at either infarction of the myocardium or ischemia. So that kind of wraps up a quick review of how to trace ECGs. This video will be up for you to go back to. In subsequent weeks, we'll just jump right into using the 6-step method to analyze the ECGs, but this will always be available that you can use as a source to kind of brush up.